Another force commutation is line side commutation. The circuit is as shown. In this type of commutation, the discharging and the recharging of the capacitor are not accomplished through the load, and the commutation circuit can be tested without connecting the load. When T2 is fired, the capacitor C is charged to 2Vs and Ts is self-commutated. When T3 is fired, this capacitor charge reverses to minus 2Vs and again T3 is self-commutated. Assuming the thyristor T1 is conducting and carrying a current of Im, when T2 is turned on, T1 is turned off by force. So when T2 is fired, which is going to make this DM diode forward biased, applies the reverse voltage of 2Vs across T1 and T1 will turn off. The discharging and recharging of the capacitor will be done through the supply. This type of commutation is known as line side commutation. This is an equivalent circuit during the commutation period where the inductor L carries the load current of Im. Now, Vs equals to L di by dt plus 1 by C integral I dt plus V of C at t equals to 0. Now, we have the initial conditions that V of C at t equals to 0 equals to minus 2Vs as well as I of t equals to 0 equals to Im. So, by substituting these initial conditions, and the solution of the above equation will get the capacitor current I of t equals to Im cos omega mt plus 3Bs square root of C by L sine omega mt, and voltage Vc of t equals to Im square root of L by C sine omega mt minus 3Vs cos omega mt plus Vs, where omega m is given by 1 by root Lc. Let this be current equation number 1 and the voltage equation be number 2. The circuit turn of time T of is obtained from the condition that is Vc of t equals to T of equals to 0 and solving the equation number 2. Then T of equals to root Lc of tan inverse of 3x minus sine inverse of x by root of 9x square plus 1, where x equals to Vs by Im square root of C by L. Let this be equation number 3 and this as 4. Now the conduction time of thyristor T2, which can be found from the condition that I t equals to T1 equals to 0. Substituting this in equation 1 and solving, you will be getting T1 equals to root Lc tan inverse of minus 1 by 3x, which equals to root Lc of 5 minus tan inverse of 1 by 3x. Let this be equation number 5. Now under no load condition, the Im is equals to 0. From equation 4, x equals to infinity. Now when you substitute these conditions in equation number 2, you are going to get the turn of time T of equals to root Lc cos inverse of 1 by 3, 1.231 root Lc. From the equation number 5, T1 equals to 5 root Lc, and this value becomes equals to 0. Now, if Im equals to 0 and T1 equals to this value, the capacitor voltage from the equation number 2 will be equals to Vc at t equals to T1 equals to 4Vs, and there will be continuous buildup of capacitor voltage. To limit the overcharging of the capacitor, the inductor L in the main circuit is normally replaced by an energy recovery transformer and a diode as shown.